First and second post of this project series, we explored our raw data set and we also cleaned the data set. So now our data set is actually really ready for our exploratory data analysis. But before we dig deeper into it, let me simply introduce the libraries that I'll be using for our visualization in our exploratory data analysis. So I've already introduced NumPy and Pandas. So next for visualization, we'll be using the libraries Matplotlib and Seaborn. Another thing I did was to set the default plot style, which is ggplot, at the very beginning because I want a consistency with all of my plots, right? And ggplot is just really easier to interpret, visuals are good, and it's also really professional. So let's dig deeper. So getting into our exploratory data analysis, right? There's a mindset that we need to have. And what is this mindset? Number one, exploratory data analysis is really beyond the pretty, fancy, colorful charts. It is really way beyond that. Because when you're getting into exploratory data analysis, you now need to know that you are listening to stories. These numbers are now people, and you have to listen to the stories, right? You are trying to answer questions really. What are the factors, what are the features that really affect the income of these people, right? What patterns am I seeing, and how do these patterns affect these people? How can we interpret these patterns? Because the insights that we get from exploratory data analysis have real life implications, so you have to have this at the back of your mind too. Okay, how can this affect real life policies? Because dealing with income prediction, the insights we get from it can have serious effect in policy making. That's like in education, in workforce development, in marketing, banking, and really so many aspects. So you need to have this at the back of your mind because it's the questions that you want to have, and it's the questions that you want to answer that will influence the chart that you use, and it will influence everything that you do basically. So it's really important to have that at the back of our mind. Also, we're going to be building a machine learning model that is able to predict an individual's income. So exploring our data sets properly also lets us understand these features better and how to better engineer these features, right, for our models. So let's get into it. The very first thing I did was to make a copy of the clean data set. Why? So that if I mess up my data set in any way at all, I can always come back to it, right? So for my validation check, even when I start my modeling, I can just come back and use the data set from here basically. Then the next thing I did was to separate my features into numerical and categorical features, right? Because there are certain investigations that I would like to make, and then they are specific to like the numerical columns, or I can just do all of the numerical columns at once. It's easier for me that way. Now next, I want to have a proper and a better understanding of my data set and the distributions. So I start with the numerical columns, right, and I plot a heat map to understand the correlation. Now I'm not going to be going really deeper into the code, each line, and what they mean. It's more about the thinking process, right, my thought process and everything, because you need to understand the data set, you need to know what you're looking for, then you get the code basically. So now this correlation heat map, there are two questions that I want to answer, right? Number one, how do these features really affect my target, which is income? And number two, are there certain features that are too related with each other? So number one, we can see that looking here, we can see education level, which is education norm, has the highest correlation, which is 0.33, followed by capital gain, and then hours per week, and then age before capital loss, right? They have the most effect on income. So this is also informing me that when I am digging deeper into these data sets, I can explore these features and we can see the hierarchy that we can follow. Again, what we can see is that there's no one feature that has like so much effect on our income. So when we're exploring, we can also use multivariate analysis where we can layer these features to see how, when they are combined, what effect do they really have on the income. So now I have seen the features and how they affect my target. Another thing is we want to see if do we have to worry about multicollinearity, meaning if any of these features are too correlated with each other, then we can just go ahead and use only one. We don't need to use like two of the same thing. So now we can see that we don't have to worry about that because none of these features are like highly correlated with each other. I clearly stated out the insight from that. I also use the method describe to view in a way the of course the statistical summary of the numerical variables, but we can also see that capital gain and capital loss, there's like a serious skew issue there. They're like highly right skewed, right? And that's also informing us on how we're going to build our model, right, during transformation. More on that during pre-processing. I wanted to have a visual picture just to visually see how my numerical features are distributed, right? And we can go ahead and see age majority of the data set, is between like 25 to, let's say, 45 or 50. We can see the distribution of all of these features. We can also see our income, and we can see that the data set is highly imbalanced, right? The people that are earning greater than 50k are not even up to 50% of those earning less than 50k. I wanted to visualize that better to have like the percentage, right? So, but before that, I came here to view and to print out the skewness of these numerical columns, and we can see it here. So now, visualizing the imbalance, right, of our targets or the whole data set, we can see that it's only 24.5% of the people in this data set, right, that earn greater than $50,000. And then a whole 75.5% earn less than or equals to $50,000. So there's a high imbalance here, and this is also going to really inform us in when we're building our model, right? Because it's possible that the model could be biased to this group that is large. So it also informs us on how to make our model better. Then I went on to, the summary of the findings we have. Next, I went to view the distribution of the categorical columns, right? And we can see that in work class, the majority is the private sector, education majority is high school, followed by these. We can really see the distribution of these categorical columns, right? Another thing I did was to print out the percentage of the distributions of all of the categories in these features, because I wanted to add the percentages here, but it just make the visualization, it's not be like so interpretable. So I printed out the percentages different, and we can then see the percentage of each category in all of these features. And then I stated out the summary from my findings. Now we're going deeper and really into the exploratory data analysis. We're now comparing these features, right? Plotting them against our target, which is the independent variable. So the target, which is the income, now is going to always be on the y-axis, which is our target variable, right? And then the other features, which are our independent variables, they are actually going to now always be on the x-axis. So now I started with age, right? Let's see how exactly does age affect income. What I can see from this chart, so I use this histogram, we can see that most individuals, right, that are less than 30 years old, they actually is only a very few number of them that earn greater than $50,000, right? Majority of them earn less than that. But we can see that the older a person gets, the more possibility that they're able to earn greater than $50,000, right? But at the age of like from 50-55, this number begins to drop. So we can see how age affects income. Next, I went to consider the education level, right? Now, I used two plots. This is the count plot, and this is the proportion plot. Looking at this count plot alone, we can see that bachelor's is the education category that has the highest number of people that are earning greater than 50k, followed by people in high school and then some college. But there's another trend here that is not so visible here, but it is very visible here. And what is that? What we get from this is that people that have attained a higher level of education actually have a higher possibility of earning greater than 50k, even though their representation in the whole data set is not that much. So you can see this, you can actually see the rise, right? People that have the highest, that's people that have doctorates and prof school, high possibility of them earning greater than 50k, followed by people that have masters, followed by people that have bachelors, and so on. So we can see that education is a good predictor of income, right? Now, I decided to also compare work hours exactly. What effect does this have? Because at this point, you also need to know that the insights that we get from our exploratory data analysis, they have real life implications, right? So we always have to have that at the back of our minds. So here we're considering the work hours. How does the work hours actually affect our income? So from the box plots, we can see that the median of the hours worked per week for people that earn greater than 50k is slightly higher than the median of people that are earning less than 50k, which means that people that are earning greater than 50k work, higher hours. But this KDE plot here showing us the distribution, really affirms that and shows us like a clear distribution and a clear flow of it. We can see that for people that are earning greater than 50K, we can see that the majority of them, it's more right skewed. So a majority of them are actually working higher, longer hours, though for both groups, majority of them are working around 40 hours, which is like the average, hours, working hours. Now, I went on to compare capital gain, right, and how exactly does it affect income. And now I use the box plot and these bar plots, right? And we can see that for both groups, people earning less than 50K and people earning greater than 50K, there's a good number of people that do not have any capital gain at all. But if you look beyond this level, there are more people in the group that are earning greater than 50K that have a capital gain, and we can see we have like a clear outlier here. So it's also evident in this chart here. So as much as capital gain is very rare in both groups, when it exists, it actually has like great influence in the income of people. I went on to compare the work class, right? Looking at this, we already saw that private has like the most when it comes to count, representation of people in a data set. So of course, it also has the highest number of people that earn greater than 50K, followed by government and self-employed are very close. But looking at the proportion plot, it tells us, like a different stories, that even though private sector has the highest number of people earning greater than 50K, people that are self-employed and people that are in the government, they actually have higher possibility of earning greater than 50K. Right? I went on to compare the marital status. So a majority of people in the data set are married and they have their spouse present basically, and they also have a higher chance of earning greater income basically. And now the proportion plot reaffirms this to us, that people that are married and their spouse are present, they actually have a higher chance of earning more. So this could maybe be due to dual income or some advantages that are given to married people. Then I went into the demographics and then I compared income by sex, income by race, income by native country, and basically at the end of the day we saw that the males, the whites, and the US natives, they dominate the data sets, right? And other really interesting findings about it that we can see here. So I went into multivariate analysis where I layered these features to see how combined, how do they really affect income. Now I combined age group and education level. We can see clearly here that for people, like we saw earlier in the education, people with the highest level of education actually have a possibility of earning higher. But even people with the highest level of education, the people that earn the most are people that are aged between 46 to 55, followed by people that are aged between 36 to 45. Right? Now we can see again that even people that have masters, we have people that are between 15 to 25 years here, but we can see that they are not even earning more. So this really confirms to us that the older a person is, the higher the possibility that they've gained a certain level of education, and the higher possibility that they have a certain experience that will make them to be able to earn more. So I went on also to compare the work class and sex, and we can see that for female and male, right, we already saw that there was a high underrepresentation of female. The female representation in this data set is not even up to 50% of the male. But if you look at something here, right, for this, which is the unemployed, there are more unemployed women than men in this data set. So this is really informing us on a lot, right? This really points towards that the job opportunities and pay opportunities are not the same, right, for both male and female, and this is really informing decision making. So far these are the findings that I have made, and next is going to be our data preprocessing and feature engineering, getting into building our model. And I know this was a bit rushed. I would have this on GitHub and I would append the link later on, but at the end of the day we're seeing that exploratory data analysis is really beyond the fancy chat. Really, it's about going deeper and asking the questions that really matter, and also knowing how can this really affect decision making, especially with what we just saw here concerning the male and the female. So those we can really dig deeper to see, okay, when it comes to getting opportunities and when it comes to even pay to, women are not really the opportunities, women are not really getting opportunities compared to men. So why is this, and how can this be improved on? Looking at education too, the higher the education a person has, the more possibility that the person will earn more. So the government can increase the education fund and how to improve education. And so these are just examples of how when you're doing your exploratory data analysis, you should also have it at the back of your mind mind of, the real world implications and how it can really affect decision making. So next we'll be going into our feature engineering and preprocessing our data set ready for building our model.